Hello friends, in this video I'll be discussing about the TRS, which stands for Tropical Revolving Storm. I'll be discussing the characteristics and more importantly how to detect and avoid it. As the name suggests, it is dangerous for the ships and navigation, and thus it must be avoided at any cost. A TRS is basically a cyclone, which is a rotating mass of warm and humid air creating thunderstorm with strong winds. It normally develops between the month of July to October in between latitudes 10° and 30° in northern and southern hemisphere. The wind speed in the TRS region goes up to 150 knots and it covers an area from 50 nautical miles to 800 nautical miles. The TRS follows a specific path in northern and southern hemisphere. However, we can never be sure about the vertex of the TRS. A TRS gains energy from the latent heat, which is received from the condensation of moist air. Thus, on hitting the land, TRS always dies out because the moisture content on land is much less than at sea. The eye of the TRS is the most dangerous point of a TRS and it must be avoided. So the question is, as a navigator, what can you do to avoid it? And the first step to that is you have to find your location with respect to the location of the TRS. To find that out, we have certain signs you can use. The first rule is that you face the true wind and the storm center is 8 to 12 points on the right in northern hemisphere and left in the southern hemisphere. Another indication to locate the eye of the TRS is observe the direction of swell. The swell is coming from the eye of the TRS. And another thing you can do is look for the densest part of huge bank of clouds. That is the eye of the TRS. Then the drop in barometric pressure is a great indication to find out how far one is from the storm center. If the pressure falls by 5 millibars, then you're more likely in the outer storm area. However, if the pressure falls 20 millibars, then you are very near to the eye. And of course, monitor the weather reports received from the shore. That gives an accurate prediction of its current path and track. Now imagine that this is a TRS in northern hemisphere. It has two semicircles, right hand semicircle and left hand semicircle, considering this is the track and this is the path of TRS. Track basically is the path which it has already followed, that means the past of the TRS, and the path which is the future of the TRS or the predicted future of the TRS. Now in northern hemisphere, the right hand semicircle is also called dangerous semicircle and the left hand semicircle is called navigable semicircle. Now instead of blindly accepting this, let's find out why is it called so. If you see this whole diagram, you see that the TRS is moving in this direction, the wind is coming from this direction. So the sum of the motion of this TRS and the wind speed causes more danger in this side than on this side. Thus, the name is given dangerous semicircle and navigable semicircle. Now that in the previous steps you have located the eye of the TRS with respect to your current position, you still do not know which semicircle are you in. So the first thing you need to identify as a navigator is which semicircle are you in. So let's say I'm on this ship. If I face the true wind, which appears to be coming like this, and I'm standing like this, then 8 to 12 points is the storm center. So this is how you get the storm center. Now I know the storm center, but I'm still not sure whether I'm on the dangerous or the navigable semicircle. So what I'll do is I'll start taking the wind observation. On the right hand semicircle, the wind always veers, and the left hand semicircle, the wind backs. And this is same for both the hemispheres, northern and southern hemisphere. And how is that happening? Let's do the same thing. If the ship is in this position and I'm entering the outer area of this TRS, I will face the wind coming from east, and as I move in, I face the wind coming from south. So what did really happen? East and then south. That means the wind is veering. If I was here, first I'll face the wind which is coming from north. As I go further in, this wind direction will change. As I'm on this layer, it will become westerly now. So from north to west, what is really happening is wind is veering. So it's same on both northern and southern hemisphere. Now we know which semicircle are we in. Now what is the best path to avoid it? The best path is to get away from it as soon as possible. So once I'm aware of the semicircle I am in, the rule is simple. If I'm on the right hand side, keep the wind on the starboard bow in northern hemisphere, 1 to 4 points. So let's see how that will help. Let's say I'm here, I keep this wind on 1 to 4 points, and then I keep proceeding. As the wind changes the direction, I change and keep the wind on 1 to 4 points, and I get out of here. So this is basically how my track will look like. I will slowly get away from it. And if I'm on the left hand semicircle, I keep the wind on the starboard quarter for northern hemisphere. So this is the wind coming from north. I keep it on the starboard quarter and I keep moving out. As I move out, the wind direction changes a bit. I change the ship's heading and I'll be out of here. So this is how you will get out of the way in northern hemisphere. Let's make a quick comparison between TRS in the northern hemisphere and southern hemisphere and how the actions will be different. In the southern hemisphere, as you know, the right hand semicircle is where the wind veers and left hand semicircle is where the wind backs. And the action taken in the southern hemisphere is quite similar to what is happening in the northern hemisphere, except that instead of taking the wind on the starboard side, either starboard bow and starboard quarter in northern hemisphere, we are doing port bow and port quarter in the southern hemisphere. So if you are in the dangerous semicircle, you will take the wind on the port bow 1 to 4 points. So if I'm on the dangerous semicircle, wind is flowing anti-clockwise, I start taking the wind on my port bow 1 to 4 points. And as I proceed like this, as the wind direction changes, I keep changing my head and slowly I will move away from the eye of the TRS, and that's the point. And similarly in the right hand semicircle, which is the navigable semicircle, if I'm on that, then I'll keep the wind on the port quarter, something like this. So the wind will keep changing, I'll keep changing my head and go away like this. So these are the basic two actions. The difficult part which I have found during my oral examination is when they are asking for northern hemisphere or southern hemisphere, how to explain that we are in the dangerous semicircle. So 1 to 4 points on the starboard bow or starboard quarter, or port bow, port quarter, whether right is dangerous or left is dangerous. So to make that easy for you, I want to tell you a story as always. So just imagine, so there is a foreigner who's visiting India. He goes to the North India and he sees this guy and says, oh, North Indian guys, they're carrying sword in their right hand. Their right side is dangerous, very dangerous people. Then he goes to the South India and he sees that South Indian people, the dangerous guys, are carrying sword in their left hand. And he assumes that all South Indian guys who are left-handed are dangerous. So the question is how to avoid these dangerous guys. See, you always have two choices, either to go head on or you show your back. Head on, you can say you keep the wind on the bow, either port bow or starboard bow, and showing your back is also the same. you keep it on your quarter, either port quarter and starboard quarter. So if you meet a North Indian guy and you see a sword in his right hand and you are on his right hand side, that means you're on the dangerous side. Then if you try to run away, the sword can easily reach you. So you have only one choice, you have to fight. So keep the wind on your starboard bow, 1 to 4 points. But if you're on the navigable side, that means on his left side, then there are chances to run. Then you can show him the quarter, 1 to 4 points. Similarly, with the South Indian guy, he is carrying a danger on his left hand side. And if you are on his left hand side, then you better face him. Go 1 to 4 points on the port bow. But if you're on the safe side, if you're on his right side, then you can go for 1 to 4 points on the port quarter. I hope this will actually make it really easy for you to answer what actions to take. For examination purpose, let's do a comparative study between TRS and TLD. TLD stands for Temperate Latitude Depression and it occurs between latitude 30 degrees and 60 degrees. And this is not as dangerous as TRS. The wind speed is as low as 50 knots. And as you can see, area covered by a TLD is 1000 to 2000 nautical miles in diameter, while TRS was just 50 to 800 nautical miles. In TLD, there are two air masses involved, and because of this, there is a lot of temperature variation as you pass through this. However, in TRS, there is only one air mass involvement, so not much of a temperature difference. And TRS travels from east to west, while TLD travels from west to east. TLD gains energy from lifting of warm air mass by cold air mass, while TRS was gaining energy from the latent heat released from the condensation of moist air. The isobar pattern changes in TLD and not much changes in TRS. And the wind speed increases with height in TLD, while the wind speed decreases with height in TRS. I hope you liked this video and it fulfilled your purpose. Thank you for watching.